constant temperature and pressure, delta G and its first and second derivatives must be continuous functions of x1 and the second derivatives must be everywhere be positive. This is at constant temperature and pressure. Okay, or you can write T square delta G by RT dx1 square greater than equal to 0 at constant temperature and pressure. So this requirement has a number of consequences. So let's discuss this. Equations for X gives free energy equation for any binary solution. We know that it can be written as GE, X gives free energy, is equals to delta G minus RT summation of Xi ln of Xi. So delta G is equals to GE plus RT summation of Xi ln of Xi. Now divided by RT throughout. So delta G upon RT is equal to GE upon RT plus summation of Xi ln of Xi. Now for any different for a binary solution, for any binary solution, this is delta G upon RT. This will be equal to x1 ln of x1 plus x2 ln of x2 plus GE upon RT. Replace x2 by 1 minus x1 in the above equation. So we have delta G upon RT is equals to x1 ln of x1 plus 1 minus x1 ln of 1 minus x1 plus GE upon RT. Now differentiate the above equation with respect to x1. So delta G upon RT dx1 is equals to, so इसका क्या हो जाएगा, first ln x1 then plus x1 upon 1 minus x1 1 minus x1 का minus 1 then ln of 1 minus x1 plus 1 minus x1 is remains same, ln of 1 minus x1 का 1 upon 1 minus x1 and minus x1 का minus 1 plus GE upon RT. So this is cancel and then 1 minus 1 plus 1 is also cancel. So therefore we get ln x1 minus ln 1 minus x1 plus, here also this is also get differentiated with respect to dGE upon RT upon dx1. So dGE upon RT upon dx1 and that will be equal to d delta G upon RT upon dx1. Now double differentiate, again differentiate the same equation. So because our criteria for the stability is the double second derivation of this will be always positive. So RT dx1 with respect to again x1. So this is 1 upon x1, this is 1 upon 1 minus x1 minus 1 ka minus 1 minus x1 ka minus 1 plus d square GE upon RT upon dx1 square. 1 minus x1 ko we can write x2. So this is 1 upon x1 plus 1 upon x2 plus d square GE upon RT upon dx1 square x1 x2, this is x1 plus x2 plus d square GE upon RT upon dx1 square, and we know that x1 plus x2 is 1. Therefore, delta d square delta G upon RT dx1 square is equals to 1 upon x1 x2 plus d square GE upon RT upon dx1 square. And we know that for the stability, the second derivative of Gibbs free energy will be greater than 0, right? So here you can put the value of this. We know that the second derivative of Gibbs free energy is greater than 0, so you can put this value over here. So 1 upon x1 x2 plus t square GE upon RT upon dx1 square is greater than 0, and d square GE upon RT upon dx1 square minus x1 x2 at constant temperature and pressure. So this is the stability criteria. Further, for binary mixtures, we know that excess Gibbs free energy is given by x1 ln of gamma 1 plus x2 ln of gamma 2. Now we can write this stability criteria in terms of activity, in terms of fugacity, in terms of chemical potential, in any potential you can write this for our convenient. जो भी आपको calculation करना होगा according as per the calculation, जो भी availability होगी data की, उसके accordingly you can use or you can derive the relationship. So the basic relationship we know that in terms of excess Gibbs free energy, right? So here we can write in terms of activity, and then similarly you can write the stability relation for in terms of uh, fugacity or in terms of chemical potential. And we know that the significance of all these um, uh, three potentials, like fugacity, you know the significance of fugacity, you know the significance of activity and chemical potential. So here differentiate this equation with respect to x1. So dGE upon RT dx1 is equals to x1 differentiation हुआ ln gamma 1, and here 1 minus x2 you need to convert 1 minus x1. Okay, so this is plus x1 d ln gamma 1 upon dx1, then x2 in place of this, so minus 1 ln gamma 2 प्लस x2 को यहाँ पर मैं लिख देती हूँ 1 माइनस x1 d ln gamma 2 dx1, right? Or you can write as x2 1 minus x, in place of 1 minus x1 you can write x2, so minus ln gamma 2 plus x1 d ln gamma 1 dx1. Here you can write plus x2 d ln gamma 2 upon dx1. Now from Gibbs-Duhem equation, we know that x1 d ln gamma 1 upon dx1 is equals to x2 d ln gamma 2 upon dx2, right? This is the various forms of Gibbs-Duhem equation which we had already discussed in our previous videos. So you can replace this x1, we know that for the binary solution this, so x1 is equals to 1 minus x2 and dx1 is equals to minus dx2. So you can replace here. So you will get x1 d ln gamma 1 dx1 minus x2, in place of dx2 what we can put minus dx1. So d ln gamma 2 upon dx1, d ge upon rt dx1 is equals to, we have ln gamma 1 minus ln gamma 2 and plus x1 d ln gamma 1 dx1, and in place of x2 d ln gamma 2 upon dx1 we can replace minus x1 d ln gamma 1 dx1. This is also x1, so this is cancelled, and then we will have d ge upon rt dx1 ln gamma 1 minus ln gamma 2. Now double differentiate this. So with respect to x1 again, ge upon rt dx1 square. So here it is d ln gamma 1 upon dx1 minus d ln gamma 2 upon dx1. Again we apply the Gibbs-Duhem equation. Again we apply the Gibbs-Duhem equation here. So we get d ln gamma 1 upon dx1, in place of this plus x1 upon x2 d ln gamma 1 upon dx1. Rearrange this. So here it is ge upon rt dx1 square. Here d ln gamma 1 upon dx1 is common, and then we have 1 plus 1 upon, sorry, x1 upon x2. So this x1 upon x2 d ln gamma 1 upon dx1. And from the general criteria which we have already derived, so we know that this equal to, see, d square ge upon rt upon dx1 square is this is equal to, what is this, minus 1 upon x1 x2. So now what we do, we just replace the left hand side of the equation, this equation by equation, this equation. So 1 upon x2 d ln gamma 1 upon dx1 greater than minus 1 upon x1 x2. So x2 x2 cancel, and then d ln gamma 1 upon dx1 is greater than 1 upon minus x1 at constant temperature and pressure. So this is the yet another conditions for stability. You can also write other stability criteria like d cap dx1 is greater than 0, d mu I upon dxi is also greater than 0, and all the conditions at constant temperature and pressure. So three criteria for stability. And last two equation, that fugacity of components in a stable solution always increase with increase in concentration. So these are the three conditions for the stability.